Hi everyone, this is Jack from Maths Forge, and in today's lesson we're going to be learning about the equation of a circle. Let's take a look at our first example. Here we're being asked to find the equation of a circle with point 3, minus 4 and center 0, 0. So when they say with point 3, minus 4, that means that this coordinate lies on the circle. Now the equation of any given circle that has a center of 0, 0 is going to be x squared plus y squared, which is equal to the radius of the circle squared. So I think the important thing for us to achieve here is to find out what the radius of the circle is. We know that the center is 0, 0, which means that the equation is going to have the form of x squared plus y squared. If we can just find out what the radius is, then we can complete this equation. So to begin, I'm going to draw a circle, and we're going to say that the center is 0, 0. So we're going to say that this point here is 0, 0. Now, this point 3 minus 4, so it's going to be 3 to the right and minus 4 down, I'm just approximating this, is going to be a point that lies on the circle, which we're going to label as 3 minus 4. So from this point 0, 0 to this point here, this is the radius of the circle. If we can find the length of this line, then we can substitute it into this equation and find the equation of this circle. Now, how do we find the length of this line? Well, we can use Pythagoras to do this. If you think about it, from the point 0, 0 to the point 3 minus 4, there is a vertical distance of minus 4. And there is a horizontal distance between the 2 points of 3. So this actually makes a right angle triangle. And we can use Pythagoras' theorem to find the length of the radius. So Pythagoras' theorem says that the two smaller sides of a right angle triangle squared is equal to the hypotenuse squared. And in this case, let's call the hypotenuse r. We're going to call it r for the radius. So that is equal to r squared. And if we simplify, we get the following. 9 plus 16 is equal to r squared. 9 plus 16 is 25. So we'll simplify this further. And this is r squared. Now, we don't actually need to rearrange for r. We can just use r squared, this 25, and input it into this equation. So the equation of this circle is going to be x squared plus y squared, which is equal to 25. And if we check our answer, there it is. Now let's do a 2-star example. Here we're being asked to find the equation of the tangent to the circle with center 0, 0 at the point 2, minus 5. So if you don't know what a tangent is, it is a straight line that touches the edge of the circle at one point. So let's label the center of this circle 0, 0. And the tangent is going to be touching the point 2, minus 5. So that's going to be 2 to the right and minus 5 down. Again, this is just an approximation of where it actually is. 2, minus 5. And the tangent is going to be the equation that passes through this point here. It just touches the edge of the circle at one point, and that point is 2, minus 5. So we need to find the equation of this line here. How are we going to do this? Well, the first thing that we need to do is we need to find the gradient between the center of the circle, 0, 0, and this point here, 2, minus 5. And the reason we're going to find the gradient of this line here, so we're going to find the gradient of this line, is because the radius of a circle touches a tangent to the circle at 90 degrees. So there's a right angle here. And we can use our knowledge and understanding of gradients to find the perpendicular gradient to this radius here. So let's begin. To find the gradient of the radius, it's going to be y2 minus y1 over x2 minus x1. And in this case, y2, I'm going to call it minus 5. And y1 therefore is 0. And x2 is going to be 2. And of course, minus 0. So if we simplify this, we end up with minus 5 over 2. And this is the gradient of the radius. So I should probably put a little r here to indicate that. Now that we found the gradient of the radius, we can actually go ahead and find the gradient of this tangent. The gradient of the tangent, which we're going to call mt, is going to be the negative reciprocal of the gradient of the radius. Because, of course, lines that are perpendicular to each other have a negative reciprocal gradient to each other. And what that means is, since the gradient of the radius is minus 5 over 2, the negative version of that, so a negative of a negative, is a positive, and the reciprocal is going to be the fraction flipped upside down, so it's going to be 2 over 5. Okay, so now we actually have the gradient of this tangent here. I'm going to go ahead and write a generic equation of any line, which is y equals mx plus c. And now we can replace the gradient part of this tangent with the gradient 2 over 5. So we have y is equal to 2 over 5x plus c. Now this plus c is the y-intercept of this line. And we can find this by taking a point on this line and substituting it for y and x into this equation. We know that this line has the point 2 minus 5 that lies on it. So we're going to take this point and we're going to substitute it into our tangent equation. So the y, which is minus 5, is going to replace the y here. And then we're going to have 2 over 5 multiplied by the x value, which is 2 in this case, plus c. Now, if we rearrange for c, we will get the y-intercept, since c is the y-intercept. So one more simplification. This is going to give us minus 5 is equal to 4 over 5, because of course 2 over 5 times 2, we times the 2 together, which gives us 4 over 5, plus c. Now we subtract from both sides 4 over 5 to get c on its own. So we're going to subtract 4 over 5 from both sides, and this is going to get us c on its own. Minus 5 minus 4 over 5 will give us minus 29 over 5. And this is our y-intercept. So now we can actually write the full equation of this tangent. It's going to be y is equal to the gradient of this tangent, which is 2 over 5, x plus the y-intercept. So it's going to be plus minus 29 over 5. So a plus and a minus makes a minus 29 over 5. Now you can go ahead and simplify this 29 over 5 to a mixed number, or you can leave it as an improper fraction. The most important thing about this question is actually getting this equation here, being able to identify the gradient and the y-intercept. And if we check our answer, there it is. Now let's do a 3-star example. Here we're being asked to find the equation of the tangent to the circle with center 0, 0 at point 4, minus 4. So our center here is going to be 0 and 0. And the point is going to be 4 and minus 4. So it's going to be about here somewhere. Let's label it. And they're asking us to find the equation of this tangent. Now, the radius is here. And just as we did in the 2-star example, we are going to find the gradient of this radius and then use the negative reciprocal of that to get the gradient of this tangent, construct a y equals mx plus c equation, and find c. So let's go ahead and do that. Let's find the gradient of the radius. That's going to be y2, which is minus 4, minus y1, which is 0, over x2, which is 4, minus x1, which is 0. This is now going to give us minus 4 over 4, which simplifies to give us minus 1. Now, this is the gradient of this radius here. To find the gradient of the tangent, which is the negative reciprocal to minus 1, so again, apply negativity to minus 1, which makes it positive, and 1, its reciprocal is just 1 over 1. So it actually just stays as 1. And I'll explain that in a bit more detail here. So minus 1 has a negative reciprocal of the following. Minus 1 can actually be written as minus 1 over 1. And the negative reciprocal of this is going to be a positive number that has the fraction flipped upside down, but it stays as 1 over 1. So the negative reciprocal of minus 1 is just 1. Now that we know this, the gradient of the tangent is 1. So we can go ahead and write out our equation of the line, y equals mx plus c. And this is the equation of the tangent. We can now replace the m by the gradient of the tangent that we found, which is 1. So it's going to be y equals, I'm not going to write 1x, I'm just going to write x, because 1 times x is just x, plus c. Now to find c, if you remember from the previous example, we're going to take a point that lies on this line, which we know to be 4 minus 4, and substitute it into this equation here. So the y value is minus 4, and the x value is 4, plus c. Now we're going to rearrange for c, which means we have to subtract 4 from both sides to eliminate this 4 here. This is going to leave us with the following. Minus 8 is equal to c. We can now write the full equation of the line to this tangent here, which is y is equal to the gradient 1x plus c. But since c is a minus 8, it's going to be plus minus 8, which makes it just minus 8. And this is the equation of the tangent that passes the point 4, minus 4 to a circle that's at 0, 0. And if we check our answer, there it is. And that's it for the lesson on equations of a circle.